Welcome to IOQM 2022. Let's see the second part of the video. In this, we'll cover questions 11 to 22. Each will carry 5 marks. So we'll cover questions from 11 to 17 in this video. Okay, one question is removed by IMO. It's not correct. Okay, let's start. Yeah. The first question is let AB be the diameter of the circle W. Okay, and let C be the point on W, different from A and B. Okay, let's see the diagram and then read the question along with. So this is the circle. Okay, this is the circle. AB is the diameter. Okay, C is any point on the circle. Okay, and there is a perpendicular drawn from C which intersects AB at D. Okay, and W at that circle W at E. Okay, circle with center C. Okay, there is another circle drawn with center at C and CD as R radius. Okay, intersect the first circle at P and Q. Okay, if the perimeter of the triangle PEQ is 24, find the length of the side PQ. Okay, PQ we need to find. Okay, so if you see if the second circle radius is R, that is CD equal to R, then PC equal to R. Okay, as well as CQ equal to R. Okay, because this is the point on the second circle, P and Q are point on second circle, C is the center. Okay, and this is a cyclical quadrilateral, which is PCQE, the cyclical quadrilateral. Okay, so obviously the CD and DE will be equal, so DE is also radius R, basically not radius R. Okay, now let's see. Okay, CPEQ is cyclical quadrilateral. So once you know this, there is a formula CP opposite sides, product of opposite sides, sum of product of opposite sides, that is CP into QE plus CQ into PE, which is equal to product of the diagonals CE into PQ. Okay, okay, so once you know this, this is very simple. Now you just substitute values of R. Okay, so R into QE plus R into PE, R into QE plus R into PE equal to 2R into PQ. So with this you can derive QE plus PE equal to 2PQ. Okay, now it is given that peripheral of triangle PEQ, that is PE plus QE plus PQ equal to 24. So you replace these two values here, you will get 3PQ equal to 24, PQ equal to 8. Okay, this is easy. You should know just cyclical quadrilateral equation here. Next, yeah, let's discuss the problem along with the diagram. ABC is the triangle and let D be any point on BC such that AD equal to BC. Okay, AD equal to BC. Okay, suppose that CAD, this is X, this is Y, this is Z. These three angles are given. Okay, and it is mentioned that X, Y, Z are in arithmetic progression. Okay, so find the largest possible value of angle ABC, that is Y. Okay, this this is easy. If X, Y, Z are in arithmetic progression, you know the relation Y equal to X plus Z by 2. Okay, or X plus Z equal to 2Y. Note down this, and then X plus Z is nothing but 2Y, right here. Okay, now angle BAD equal to 180 minus X plus Z plus Y, correct? And X plus Z is 2Y, so 180 minus 3Y. Okay, this should be greater than 0. We know angle, the angle in a triangle, it should be greater than 0. For this to be greater than 0, 180 should be greater than 3Y, or Y is less than 60. Okay, so what is the maximum value which you can think of? It's 59. Okay, so angle ABC is 59, maximum possible value. Okay, this is easy. Next. Okay, let x, y, z are complex numbers such that, okay, three equations are given basically here. If you see, all the denominators are same. Okay, and only thing changes in the numerator. Here it is x, y, z each term. Here each term numerator is x square, y square, z square. Here it is x cube, y cube, z cube. Okay. Now we need to find out the value of this one in terms of m by n and then find m plus n. Okay. So our first target is to find this value. If you look at this, okay, if you simplify this, basically, if you take an LCM, you get xyz as denominator and each one as x square plus y square plus z square. Correct? So if you can find x square plus y square plus z square value and xyz value, then you got the value. That is nothing but m by n. Okay. So let's go with that. Okay, so first equation I have taken and I'm multiplying with x plus y plus z. Okay, on both sides, so it is 9 into x plus y plus z. So now if you see, if you simplify, you get this value. How you will get x plus y plus z? I'm multiplying with x, right? First term x, so x square I will get, which is here anyway. What happened to the second term? Second term is basically y plus z into x. So y plus z numerator, this gets cancelled, so one x will remain, so I wrote it here. Okay, similarly for the second term you get y square and y, z square and z here. Okay, this is nothing but 9 times xyz, and we know that this is value is given, which is 64. Okay, and if you subtract here, you get 8 times xyz, x plus y plus z equal to 64. So x plus y plus z equal to 8. This is one equation, you remember. Okay, similarly for x square by y plus z plus y square by z plus x plus z square by x plus y, you again multiply with x plus y plus z, you get x cube, y cube, z cube term plus x square plus y square plus z square. Okay, now you solve it. What you will get is x square plus y square plus z square equal to 24. So now we have at least a numerator of this expression, right? Numerator we have. We need to find the denominator, which is xyz. Okay, so let's see. You need to remember this equation, xy plus yz plus zx equal to x plus y plus z whole square minus, okay, x minus, there is a bracket here, I'm just missing, minus x square plus y square plus z square. Okay, there is a bracket, that means minus x square minus y square minus z square divided by 2. Okay, so you substitute all the values, what you will get is 64 minus 24 by 2, which is equal to 20. So this is 20. Okay, okay, now given this equation, okay, x by y plus z, that is first equation I am taking, and I'm adding plus 3 on both sides of LHS and RHS. Okay, why I'm adding, I can call it 1 plus x by y plus z, 1 plus y, basically I'm adding 1 plus to each term. Okay, it is equal to 12. Now if I take a expand this, basically y plus z plus x, that is x plus y plus z here, numerator will be, okay, here also x plus y plus z numerator will be x plus y plus z. Okay, so I'm taking this common, and 1 by y plus z plus 1 by z plus x plus 1 by x plus y equal to 12. Okay, so what I got is this expression. Okay, this expression is 3 by 2. Okay, you understand to this point? We are trying to derive xyz value now. Okay, you can find any other way which is better. Okay, now this y plus z is nothing but 8 minus x, because x plus y plus z equal to 8. So that's what I have done is x plus z is 8 minus y. This is 8 minus z, which is equal to 3 by 2. Now this is very simple. I just expand it, basically. This is the values you will get. 8 minus y into 8 minus z plus 8 minus z into 8 minus x plus 8 minus x into 8 minus y divided by this equal to 3 by 2. Simplify further. Okay. And replace all the values which you have. Okay. What you will get is basically this expression. Finally, you will end up in this expression. Okay, and this also you further do, simplify further, do it yourself, you will get xyz as 104. Okay, now we have all the values x by x yz plus y by xz plus z by xy is nothing but x square plus y square plus z square by xyz, which is equal to 24 by 104. Okay. Yeah, I don't know why I wrote this. This is wrong actually. Okay. This should not be here. 24 by 104 equal to 3 by 13. That is nothing but m by n. So m plus n is 16. That's the answer. Okay. So this is a bit hard. You need to have that how you can simplify and get x square plus y square plus z square from this expression and xyz from these expressions. Okay, that you should know. So this comes only by practice, practice, and more practice. Next, let xy be real numbers such that xy equal to 1. Okay, and let it capital T and small t be the largest and smallest values of the expression given here. Okay, find the value of p plus t in the form of m by n and then give the value of m plus n. Okay, the first target is to find largest and smallest values of this expression. Okay, so if you see this expression, what we can easily see, if I can make this x minus 1 whole square form, okay, then everything is a square minus a minus 2 b square plus a minus 2, correct? How do you convert that? X plus y whole square to x minus y whole square is basically x minus whole square plus 2xy. Xy is 1, given as 1, right? Xy. So plus 4. Sorry, x minus y, x plus y whole square equal to x minus y whole square plus 4xy. Xy is 1, so plus 4. Okay. Then other things are same. I kept it. So this is what you will get. Okay. Now let take some value m as x minus y. Okay. Just note down this m is not same as this m. Okay. Then the expression will become m square minus m plus 2 divided by m square plus m plus 2, which is equal to k. Okay. We need to find out this k value. We are interested in this k. Okay. In a fractional form. Okay. So m square minus m plus 2 equal to k times uh, the denominator comes to the RHS side, m k into m square plus m plus 2. Expand it further, what you will get is k minus 1 into m square plus k plus 1 m plus 2k minus 2 equal to 0. Now you know that k should have some uh, real values. For k to for k plus 1 to have some real values, basically the determinant of this quadratic equation should be greater than or equal to 0. So determinant is nothing but k plus 1 whole square minus 4 times k minus 1 into 2 times k minus 1. So 8 times k minus 1 whole square, which is greater than or equal to 0. You again expand it, what you will get is 7 says minus 7k square plus 18k minus 7 greater than or equal to 0. Or if I take minus both sides, if I remove minus, the greater than or equal to will become less than or equal to, right? So 7k square minus 18k plus 7 is less than or equal to 0. Okay. Now k will have two roots. Okay. And any quadratic equation, sum of two roots is minus b by a. If it is a square, ax square plus bx plus c equal to 0, sum of two real roots equal to minus b by a. So same thing if I apply here, what I will get is sum of two roots p plus t equal to minus 18, minus of minus 18, that is 18 by 7. Okay, which is m by n. And the answer is what we are looking is m plus n. Okay, so m plus n equal to 18 plus 7, which is 25. That's the answer. Okay, so this is at least moderate. You can easily clearly see here that you can convert this into x minus y. Then it's just playing with the quadratic equations. Okay, next. Let ABC be real numbers satisfying 3AB plus 2 equal to 6B and 3BC plus 2 equal to 5C and 3CA plus 2 equal to 4A. Let Q denote the set of all rational numbers given that the product ABC can take two values R by S belong to and T by U belong to Q. These two values. Okay. In the lowest form, find this value. Okay, this r by s and t by u are in the lowest form, which means basically you can't divide them further. Okay, we have three equations. Basically, two of them you get into single variable first. Okay, very easy. Three equations, three variables, right? You replace first make them into single variable like 3ab plus 2 equal to 6b. So a equal to 6b minus 2 by 3b. 3bc plus 2 equal to 4c. So c is equal to 2 by 5 minus 3b. Substitute these two in the third equation. What you will get is this one. Okay. Now you multiply both sides with 3b into 5 minus 3b. What is that? This denominator basically. Just to remove the denominator. Then what you will get is, you carefully check. Okay. 3 into 2, 6. 6 into 6b minus 2 plus. Okay. Here you will get 3b into 2. That is 6b into 5 minus 3b equal to 3b. 3b gets cancelled. So here you will get is 4 times 6b minus 2 into 5 minus 3b. Okay. You simplify this. Okay. What you will get is 27b square minus 39b plus 14 equal to 0. Now we know that this is a quadratic equation. So you can factorize or you can directly find from the equation what the values you will get is b equal to 2 by 3 or 7 by 9. These are the two values you will get. Okay. So once you get this, for each value of b, you find a and c. Correct? A and c are in terms of b already. You find out. Okay. For b equal to 2 by 3, you will get a and c as a as 1 and c as 2 by 3. Okay. And abc equal to 4 by 9. This is nothing but r by s. For b equal to 7 by 9, a equal to what you will get is 24 by 21, or simplifying, you will get 8 by 7, c equal to 3 by 4. So ABC equal to 2 by 3. This is equal to t by u. So r plus s plus t plus u equal to sum of these four, which is nothing but 18. Okay. Hope it is clear. It is just a long work, but problem is not that complex. Okay. Next. Okay. This is a hard problem. Already I put it. Let's see. For a positive integer n minus 1, let Gn denotes the largest positive proper divisor of n. Okay. Which is, what is the meaning of this one? Gn denotes the largest positive proper divisor of n. So if n is 10, is given example here. If n is 10, Gn is the biggest divisor, which is 5. Correct? That is what Gn denotes. Then f of n equal to n minus g of n. Okay? If n is a prime, this is 1. Correct? We know. This is 1 is the largest proper divisor of a prime. Okay? If, so if n is a even number, then obviously half of that number, basically half of the given number is the largest proper divisor, right? So you have to, I mean, once you see this factors and divisors, all those things should come into your mind. Okay, only then this problem can be solved. That's the reason I said this is hard before, just for you to understand very carefully. You should look into the each line here. Okay. What we need to find out is function of n equal to 97. This is given. Find the largest integer not exceeding square root of n. Okay, what should be this n value so that you get 97 here? Okay, then you give the value of square root of n. That's the thing. So let's first yeah, look at this one. Okay, first thing you need to understand, if f of n equal to y and y is a prime. Okay, what is the meaning of that? If y is a prime, okay, y is a prime, then only way is n has to be twice the number, twice the prime number. Only then you get that value. Correct? Yes or no? If y is 20, then y is like, let's say 24, then what is the value you'll get? Okay, 12 is the I mean, it can have any value, but let's say y is 7. It has to be 14. Correct? N has to be 14. Then 14 minus 7. 7 is the biggest factor, right? Of 14. So 14 minus 7, you get 7 here. So if it is y is a prime, obviously n has to be twice the number. That is 2y. Okay? Remember this. This problem is hard only because you need to get your understanding of prime numbers, complete number theory actually. Okay? Now, if f of n equal to x and x is a composite number, but x plus 1 is a prime. Let's take an example. Okay? So that means we should take a one short of prime number. What is that number? Let's take uh, 10. Okay? Because 10 plus 1 is a prime. Correct? 11 is a prime. Okay? So x equal to 10. Then what has to be n? If x equal to 10, n has to be 11. Yes. If it is 11, okay, if n is 11, the factor, highest factor is 1 because 11 is a prime. Correct? 11 is a prime. So factor is maximum, biggest factor is, biggest divisor is only 1. 11 minus 1, you will get 10. Correct? So if x is a composite number and x plus 1 is a prime, then n equal to x plus 1. Okay? Note down these two. Okay? Few more will come. Let's check the now. F of n equal to 97. So we know 97 is a prime. So this f of n, this f of n has to be what? As per the first rule, twice. Correct? So f of n equal to twice 97. Correct? Now, next. Now f of n equal to f of n for n to be least can be 3 times or 4 times. Now, this f of n value is what I'm trying to tell is if this is twice the prime number, this has to be, okay, this has to be either 3 times the prime number or 4 times the prime number. Okay, why? Let's take an example, smaller number. If it is, let's say, if it is 2 times 7, that is 14. Okay, then this has to be, what I'm trying to tell is either 21 or 28. Okay, if it is 21, what is the largest divisor? 7 still. So 21 minus 7 is 14. So 2 times 7. If it is 28, what is the largest divisor? 14. So 28 minus 14 is 14. Correct? So it has to be either 3 times or 4 times. Okay? Now once you understand that, this is very easy. Now f of n will become two cases are there. Either 3 times 97 or 4 times 97. Let's take first case. F of n equal to 3 times 97. Okay? Then least value of n equal to 6 times 97. Correct? Least value of n equal to 6 times. Okay, you can cross check again. Take an example and try it. Okay, next. If f of n equal to 4 times 97. Okay, then the plus 1, next number is basically a prime. Okay, 4 times 97 is 388. So 389 will come. It's a prime. So this will be n can be 4 times 97 plus 1. Okay, now out of these two values of n, which is smallest? Because it's n be the smallest positive integer. Okay, that's given. N should be the smallest positive integer that is possible for this. Okay, okay, so that means this value. Correct? So you take n equal to 4 times 97 plus 1. Okay, this is your n. Then we need to find the square root of n. Square root of n is 389. Square root of n is it ranges from 19 to 20. Okay, not exceeding square root of n. So it cannot exceed. So 19 is the value. Correct? If you take 20, it exceeds. 19, it won't exceed. So 19 is the largest integer possible for square root of n, which is 19. Okay. So now you understand why I said this is very hard. You have 3 or 4 number theory theorems which you are applying here actually. I just put equation 1 here, equation 2, but this is another one, third, fourth. There are actually, we used four, at least four things here basically. Okay. So this is very deep into the number theory. That's why it is hard. Thank you. Let's see the next videos for continuing this IOQM 2022. Thank you.